Chapter 3, Section 6, Systems with 3 Variables. What we're going to learn today is we're going to learn to solve systems in 3 variables by elimination and substitution. Okay. When a solution of a system of equations in 3 variables is represented by 1 point, you can write it as an ordered triple, x, y, z. You can solve a system of 3 equations in 3 variables by working with the equations in pairs. You need to use one of the equations twice. So for the first example, solve by elimination. We like to number our equations to kind of help it keep order of everything. So equation number 1 is x minus 3y plus 3z equals negative 4. All right, equation number 2, 2x plus 3y, 2x plus 3y minus z equals 15. And equation 3 is 4x minus 3y minus z equals 19. Okay, so that's the original set. So by inspection, what we can see right now is the 3y and negative 3y are opposites, and I have a negative 3y as opposites. So odds are it would be beneficial for us to use equation 2 twice and start our elimination. So first thing we're going to do is write equation 1 again. X minus 3y plus 3z equals negative 4. Now what we're going to do is we're going to write equation 2 right below it. 2x plus 3y minus z equals 15. Okay. So before we do any work, let's go ahead and set the rest of it up. So let's write equation 3. 4x minus 3y minus z equals 19. And the inverse was, or the additive inverse, or the opposite was number 2. So we'll rewrite that. 2x plus 3y minus z equals 15. Okay, so we're going to start with this set first. And we're just going to add the 2. So x plus 2x is 3x. Negative 3y plus 3y is 0. So we're not going to put anything there. Plus 3z minus z, so that's plus 2z, equals negative 4 plus 15, which would be 11. So we'll label this new equation as equation 4. Okay, go to the right side. Do the same thing. 4x plus 2x is 6x. Negative 3y plus 3y is 0. Minus z is negative 2z. 19 plus 15 is 34. So that's equation 5. Okay, so now I have 2 new equations with 2 variables. So now let's manipulate those the best we can. So let's rewrite number 4 over, since 4 is right there. We'll write number 5 right underneath it and see what we have to do. 6x minus 2z equals 34. Well, fortunately for us, the z's are already opposite, so we can just add these 2 together. And I'm going to get 9x plus 0z equals 45. So 9x equals 45. Divide each side by 9. I'm going to get x equals 5. Okay, now, since I've solved for x equals 5, I can plug that back into equation 4 or 5, either of the 2 variable equations, and solve. Okay, solve for z. So I'm going to plug it in right here to equation 5. So equation 5, if you look at it, was 6x minus 2z equals 34. Plug in our value of x, so it's 6 times 5 minus 2z equals 34. So that would be 30 minus 2z equals 34. Subtract 30 to each side. I'm going to get negative 2z equals 4. Divide each side by negative 2. I'm going to get z equals negative 2. Okay, now I can plug in any of the three original equations we have and solve for y. Does not matter which one. Okay, since we have equation 3 right here, we will just use it. So 4, my x value is 5, so 4 times 5 minus 3, we're still trying to solve for y, minus z, which was negative 2, equals 19. So 4 times 5 is 20, minus 3y, negative 2 is plus 2, equals 19. So I'm going to have 22 minus 3y equals 19. I'm going to subtract 22 to each side, so I'm going to get negative 3y equals negative 3. Divide each side by negative 3, I'm going to get y equals 1. So my ordered triple is x, y, z, so it's 5, 1, negative 2. And again, we can always go back and plug that in and check. So going on to the next one. So I got 2x plus y minus z equals 5. 3x minus y plus 2z equals negative 1. X minus y minus z equals 0. All right, so let's go ahead and label those equation 1, 2, and 3. All right, we're going to use equation 1 twice because that is the one that has the opposite of negative y. So here's how we'll write it up. We're going to write equation 2, which is 3x minus y plus 2z equals negative 1. We'll write equation 3 over here. X minus y minus z equals 0. Now I'm going to write equation 1 underneath both. We're going to try to do our best to eliminate the y. So I get 2x plus y minus z equals 5. I get 2x plus y minus z equals 5. So here we go. We'll do the first one. We'll add them together. So 3x plus 2x is 5x. Negative y plus y cancels. 2z minus z is minus z. Negative 1 plus 5 is 4. So I get, for my new equation number 4, 5x minus z equals 4. Okay, doing our new equation 5 on the right, we'll add everything. X plus 2x is 3x. The y's cancel. Negative z net minus z is minus 2z. 5 plus 0 is 5. So I get 3x minus 2z equals 5. Okay, so I don't have a perfect match, but what I can do is I can multiply equation 4 by 2. So let's write equation 4 again. 5x minus z equals 4. We're going to multiply that by negative 2. And what are we going to get? So negative 2 times 5x would be negative 10x. Negative 2 times negative z would be plus 2z. And negative 2 times 4 would be negative 8. So now we can just add these up for a new equation number 6. So 3x minus 10x is negative 7x. And again, this is equation 6 for us. The z's are going to cancel. The z's are going to cancel. So I got 5 plus. All right, next problem. Solve by elimination. I went ahead and pre-numbered the 3 equations. What do we notice? We notice the y's are opposites. So we'll end up using equation 1 twice. So let's write down equation 2. 3x minus y plus 2z equals negative 1. On the other side, we'll write equation 3. X minus y minus z equals 0. So we're going to write equation 1 twice. That's the one we're going to use. 2x plus y minus z equals 5. 2x plus y minus z equals 5. So we're going to come up with a new equation. We'll come up with equation 4. We're going to add these since we have opposites of the y's. 3x plus 2x is 5x. The y's cancel. 2z minus z is a positive z. Negative 1 plus 5 is 4. So I came up with a new equation. Okay, over on this side, on the right side, we're going to come up with a new equation as well. X plus 2x is 3x. Negative y plus y, 0. Negative z plus negative z is negative 2z equals 5. All right. So what we notice, if we take equation 4, I'm going to rewrite it. 5x plus z equals 4. What we find out is if we multiply that by 2, we can cancel the z's. So let's rewrite that by multiplying by 2. So that's going to be 10x plus 2z equals 8. So we can sum like terms. Or sorry, not sum like terms, but add the two equations together. So I'm going to get 13x. The z's are going to cancel, and it is going to equal 13. So we know, divide each side by 13, x is going to equal to 1. Okay, now we can plug that back into one of our new equations. I'm going to choose equation 4. So x equals 1. I'm going to put it in equation 4. So when I do that, I get 5. My x value is 1. So 5 times 1 plus z equals 4. So 5 plus z equals 4. I'm going to subtract 5 to each side. And we're going to get z is equal to negative 1. So I have my x and I have my z. I need to solve for y. Okay, looking and inspecting, I'm going to do equation 3. Okay. So here we go. So equation 3, I had x minus y minus z equals 0. My x value is 1, so add 1 minus y minus my z value is negative 1 equals 0. So I'm going to get 1 minus y plus 1 equals 0. So I'm going to get 2 minus y equals 0. Just subtract y over. 2 equals y. So my ordered pair is my x is 1, my y is 2, my z is negative 1. Okay? So on to the next equation.